All right, we got to do a trig problem, initial value problem. All right, so again, if it says here's f prime, find f, and you're actually finding c, they're not going to say find c, but they want you to find the function such that f of pi over 2 equals 4. So they're giving you info about f, right? That's not a calculus thing. This is the calculus part. Here's the derivative. So now we find f of u because it's the antiderivative of this. So the 2 will come along for the ride. What's the antiderivative of cosine? Sine. What's the antiderivative of sine? Negative cosine, right? If I just did this, it'd be wrong because I'm checking it in my head, right? Derivative of sine is cosine, check. But derivative of cosine is negative sine, so that would mess that up. So I got to adjust the algebraic sign to plus. And now if I took the derivative of this, 2 comes along for the ride. Sine, derivative of sine is cosine, check. Derivative of cosine is negative sine, check. Okay, and then don't forget your plus c. That's all the antiderivatives, but they're asking us to find one antiderivative such that f of pi over 2 is 4. So let's do it. F of pi over 2. So I just rewrite the antiderivative, but I plug in my input. And I say, well, that has to be equal to 4. And then that should allow me to solve for c. I should be able to solve this thing for c. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So that's 2 plus c equals 4. Subtract 2, c equals 2. Okay, so then don't forget, don't give me that as your answer. Go back to your function where you had the c and replace c with what you found it to be. And that is my answer. That has there's two conditions. It has this derivative and it satisfies that condition. Okay? So a real common type of initial value problem that we can work with is this velocity problem that we've been working with a lot. Okay, so remember here's what we learned before. We had a position function, and then if we took the derivative of that, we got the velocity function. And if we took the derivative of that, we got the acceleration function. Okay, so we'll use that connection and we'll do initial value problem. And now they're giving us acceleration, so we're going to have to do it twice. So let's see what that looks like. So if the acceleration is just a constant, then that means the velocity function is the antiderivative of the acceleration function, which means that's just a constant. So the velocity function looks like that. Okay, so that's one step. We did one antiderivative to get to the velocity. And then they say, okay, well, wait a minute. This has to be used. This should allow me to find c. So that's my velocity function. So v of 0 equals negative 36, 0 plus c, and that's equal to 24, which of course is telling me that c is 24 because this would just go away. Okay, so now I have more information. I know that my velocity function is negative 36t plus 24. And now I can find my position function because it's the antiderivative of the velocity function. So we're just going backwards. We've done this before in one direction. We went position, derivative, derivative. Now we're going this way. Okay, we're going from acceleration to position. So let's do it. Negative 36 comes along for the ride. T squared divided by your new power. 24, tack on a t since that's constant, and then plus c. And now I can use my last bit of information. Good thing they're making these easy for us. S of 0 equals 0. So I think that says that would be gone. That would be gone, making c output 0. Okay, so that means this c is 0. Maybe we should be a little more careful. And what you should do is call this like C1 so you don't get confused. And then when I do it again, I guess that should be C2 since they're not really the same thing. C2 would be 0, so that's gone. So my final answer for my position function is, let's reduce this. 36 over 2 is 18. and then plus 24t.